Good morning, everybody. Today we are discussing the nuclear fission reaction. So, the nuclear fission reaction means it is the splitting of a heavy nucleus when bombarded with a suitable atomic subatomic particle. Usually, we are using the neutron because the neutron are have no charge. That's why we are using the neutron for bombarding the heavy nucleus, and it will break into two fragments of comparable masses with sustainable release of the huge amount of the energy is known as nuclear fission reaction. See here, this is the one of the example, uranium 235, and uranium 235 is bombarded with a neutron, and this neutron combined with this uranium nucleus and to form a unstable nucleus, that is uranium 236, and after that it will split into two smaller nuclei of the barium 141 and krypton 92, and also one or two neutron is also eliminated from this reaction, and tremendous amount of the energy is released during nuclear fission reaction. There are some of the nuclei, and these nuclei are known as the fissile nuclei. Example, uranium 233 and plutonium 239. For these nucleus, we are using thermal or slow neutron for the bombardment. So, these nucleus are known as the fissile nuclei, whereas for the uranium 238 and protactinium 231 and thorium 232, we are using the fast neutron for the bombardment. That's why these nucleons are known as the fissionable nuclide. Now we are moving into the liquid drop model of the nuclear fission reaction. We know that we can compare this nuclear fission reaction to a breaking up of a spherical liquid drop into the smaller droplet. See here, first of all, in nuclear fission reaction, as in the case of the liquid drop, it will absorb a subatomic particle. Usually we are using the neutron. So before that, our target nucleus are in a spherical shape. After capturing this subatomic particle, it will deformed into ellipsoidal shape, and it is a heavy nuclei and it is really unstable. So it is deformed into dumbbell shape. After that, we know that the dumbbell shape is highly unstable due to the repulsion of the positively charged nucleus in the two end of the dumbbell. That's why it is readily deformed and split into small nuclei, and the shape of the small nuclei are the spherical shape. Okay, so this reaction, that is, this is the reaction which is occur in nuclear fission reaction, and this is very much similar to the breakdown of a spherical liquid drop into smaller droplet. So this is the liquid drop model of a nuclear fission reaction. It is a very important and frequently asked university question. So now we are moving into next important question, that is nuclear chain reaction or fission chain reaction. So the name indicate that this is a nuclear reaction and fission reaction is occurs in the nucleus. So during the fission reaction, one or two neutrons are eliminated in every nuclear fission reaction. These neutrons are bombarded with the next target molecule which is available in the same material, and it will undergo the nuclear fission reaction, and again it will liberate the neutron, and this process is propagated within a very fraction of seconds. That's why the nuclear fission reaction is an self-sustainable reaction. But there are two conditions. If the secondary neutron is not lost from the material, the second condition is adequate quantity of the target material is available in the reaction. If these two conditions satisfy, the nuclear fission reaction uh, can be proceed as a self-sustainable reaction, and this is the principle of a nuclear reactor. So this reaction is known as nuclear chain reaction or fission chain reaction. Now, next is an important definition, that is critical mass. What do you mean by the critical mass? We have already discussed that the two condition which is used for making the fission reaction as a self-sustainable reaction is that we have adequate quantity of a fissionable material. So adequate quantity means the minimum amount of the target molecule material required to sustain the fission chain reaction at a constant rate is called critical mass. If we have the critical mass, we can continue the fission reaction as for the nuclear reactor. So the definition of the critical mass is very important. If you are using the uranium 235 as a is a fissionable material in a nuclear reactor, we will get 200 million electron volt of the energy. So if we are using the above principle in nuclear reactor, this nuclear reactor have many application. This nuclear reactant can be used in the production of the thermal energy, or we can use for the constructive purpose, and it can be also used for the production of the electricity. But the same fission reaction can be used in the destructive purpose. For example, atom bomb. Same nuclear fission reaction is also used in the atom bomb, but the condition is we are using uncontrolled fission chain reaction in the atom bomb. That is the difference between the nuclear reactor and atom bomb. So in nuclear reactor, we are doing the nuclear fission reaction in a controlled manner, whereas in the atom bomb we are using the same fission process but in an uncontrolled manner. Hope you understood the concept. Thank you.